So I'm here at the Java doc for java.util.stack. And our first thought is going to be, oh, well, that's really cool. Java has, the JDK has a stack class. We'll just go ahead and use it. But there's a but. If we read the documentation, we'll see that the Java team recommends that we not use this class. It says right here, a more complete and consistent set of LIFO stack operations is provided by the DQ interface. Remember, because stack is an abstract data type, the behavior is most likely going to be dictated by an interface. And so it's saying, the documentation is saying that instead of using the stack class, we should use a class that implements the DQ interface. In the Q section, we'll learn more about what this DQ interface is, but we can see in the docs that there's an array DQ class. Right here, they're suggesting that one of the classes we could use that implements the DQ class is an array DQ. And if you think that means it's a DQ backed by an array, you get a gold star. So if we wanted an array implementation of a stack, this is one of the classes we could consider using. That's one option. But we've already seen another class that implements the DQ interface, and that's the linked list class. The linked list class in the JDK implements the DQ interface, and implementing a stack using a linked list is a great choice because we don't have to worry about resizing the stack when we're pushing items. So what this means is if you want a stack in your Java application, you can go ahead and just use the linked list class. One potential problem with this is the class allows us to do more than push, pop, and peek items. I mean, we looked at the linked list class, and you can add items, you can remove items, you can get the index of items, and you can randomly access stuff in the list. So you could, in your code and your use of the linked list class, just limit yourself to calling the push, pop, and peek methods. Let's go to the linked list class. Let me see. Well, actually, let's go to the DQ class, and from there we can get to the linked list class. So I'll go to the DQ class, and then we can get to the linked list class from here because it implements it. So you'll see that in the methods, because this class implements the DQ, and if we look at the DQ briefly, we'll see that it has peek, pop, and push. So because of that, the linked list class has pop, peek, and push. And if we wanted this linked list to behave like a stack, we should really only be calling those three methods. So you have two choices. You could just enforce that yourself in your code, or you could create a class that has this linked list as a field. So essentially, we'd create a stack class, and it would have a field for the linked list. And so the only methods you would expose from that class would be push, pop, and peek. And that's what we're going to go through here. So instead of using our own implementation of a linked list and using that to back a stack, we're going to use the JDK linked list class, and we're going to write an implementation that uses this class to back a stack. And so let's go over to the IDE. So here we are back in IntelliJ. I've created a new project, and I've put the code into package academy.learnprogramming.linkstack. I've copied over some code into the main method. I've copied the code for creating the usual employees, and I copied over the stack calls we made in the last video just to give me a head start. And then as usual, I've added the employee class, and it's exactly the same as it usually is. So let me add a class now called linkstack. And in here, all we need is one field. So I'm going to say private linked list, and this linked list is going to hold employee instances, and that's going to be our stack. And so this is the JDK class, java.util.linkList, and this is what's going to back our stack. And so in the constructor for linked stack, we're going to create our linked list. So we'll say stack equals new linked list. And to avoid having to change the language level, I'll just specify that we want employee. Now, one thing to remember is this linked list is actually a doubly linked list. And for a stack, you don't need a doubly linked list because you're always working with the item that's at the front of the list. But normally memory won't be an issue, and so you can just go ahead and use this linked list class. If memory was an issue, then you would have to write your own singly linked list class or use an array instead. You could look at the other classes that implement the DQ interface and see if one of those would be more appropriate. Okay, so let's add our push, pop, and peek methods. So we'll say public void push, and we're going to push an employee. And all we're going to do here is defer to the linked list. So stack.push employee, because we know our linked list class, the linked list class in the JDK implements the DQ interface, so it has push, pop, and peek methods, and so we're just going to call them. And then we'll say public employee pop. We'll just say return stack.pop. And finally, we'll have public employee peek. And we'll return stack.peek. And that's it. That's our stack implementation. Now we could implement an isEmpty method like we had in our other stack. So let's do that. Public boolean isEmpty. And we just return stack.isEmpty. And we're done. Now we went through this exercise because we want users of our stack that's backed by a linked list to only be able to call push, pop, and peek. If we use the linked list directly as a stack, then somebody might come along, perhaps a new developer on the team or something like that who's not familiar with what we're doing, and start calling other methods like add and index of and stuff like that. And we don't want that to happen. So we want a class that behaves like a stack. So you can only work with the last item that was added. You can only call push, pop, and peek. And so that's why we went through this exercise. So when we push an item, we're adding it to the head of the list. When we pop an item, we're removing it from the head of the list. And when we peek at the item, we're basically just returning the head of the list, but we're not removing it from the linked list. So last thing I'm going to do is add a print stack method. So I'll add that in here. So I'll say public void print stack, and I'm going to use a list iterator. So I'll use iterator equals, and it wants to know which class, which list iterator I want. Ask me again. Oh, there we go. So I want java.util, and we're going to call stack.listIterator. And then we'll just say wall iterator.hasNext system.out.println iterator.next. Now this iterator traverses the list from head to tail, and in a linked list implementation of a stack, the top item is always at the head. So just like when we implemented a stack backed by an array, when we print out the stack, the top item will be printed first, followed by the item that's below the top, etc. So it'll be printing from the top down. So now let's go back to our main method, and I'll first remove the print stack. We haven't created our stack yet, so I'll say linked stack equals new linked stack, and let's push all our employees. So we'll say stack.push Jane Jones, stack.push John Doe, stack.push Mary Smith, stack.push Mike Wilson, and stack.push Bill End. And then we'll print our stack. So let's run. And we'll see that Bill is at the top of the stack, followed by Mike, Mary, Jane, and John. So let's peek at the stack and see what we get, and then we'll print our stack again to show that we didn't remove anything. I'll comment this print stack out. So let's run. And we'll see Bill twice because this print line here is from peeking at the stack. And then when we print the stack out, Bill is still on the stack. He wasn't removed. And then finally, we'll pop the item off at the top of the stack, and then we'll peek at the top item. So let's run. And we'll see that we popped Bill, and the next employee, or the employee that's on the top of the stack after Bill is popped, is Mike. And that's exactly what we saw when we implemented a stack using an array. And once again, with a linked list implementation, the time complexity for push, pop, and peek is O of 1. It's constant time because we're always working with the item at the head of the list. And so the steps involved don't depend on the number of items in the list. Now, if we try to do something like stack.add with an employee, you'll see that we can't do that because that's not really a stack operation, or stack.get a certain employee. So even though the linked list class has those methods, if we come in here, and I'll just say stack.add, you'll see that there's the add method, or stack.get. You'll see there's a get method where we can specify a position in the list. Even though the linked list class has those methods, we don't want people to be able to call those methods because then our stack wouldn't be behaving like a stack. And so that's why if we wanted a stack and we wanted all the developers on the team to only use the class as a stack so that they can only push items, pop items, and peek at items, then we just wrap the linked list with another class and we only expose push, pop, and peek methods. And you can expose stuff like isEmpty. That's not allowing them to do something to the stack that they're not supposed to do. And that's it for stacks. They're not all that complex a data structure, especially once you understand linked lists and arrays, because all a stack does is limit the operations you can do on whatever data structure is being used to implement the stack. I'll see you in the next video.